Okay, solving polynomial equations, review fundamental theorem of algebra. So let's take this problem for instance. Solve for all zeros, roots, solutions. We've talked about how zeros are the same thing as the roots, which are the same thing as the solutions. They're kind of all, that vocabulary is used together all the time. Okay? And after you do that, then let's write the polynomial in factored form. First of all, y equals x cubed minus 6x squared plus 3x plus 10. How many roots, zero solutions will this one have, and how do you know? 3 because
Highest exponent.
Highest exponent. That's the degree of the polynomial. Good job. Highest power, that determines how many zeros there are. Okay, so let's find them. What are they?
We have to use synthetic division. Subtract
I would
10
go.
over.
Huh? Graph it? Can you just look at this and say, oh, I can tell 4 is a 0?
It's actually 3.
If you can, tell me how you do that. Okay? Because I can't. All right? You could start guessing and checking. You could plug numbers in for x and see if you get 0 for y. You could use the rational root theorem that we talked about in Algebra 2 and list all the factors of 10 divided by the factors of 1 and see if any of those numbers would satisfy. Okay? That's before graphing calculators back in my day. What we'd have to do, we'd make the list and then we start guessing and checking from that list, so that way at least it's a narrowed down list. Okay? But yes, graph it. Graph it, maybe you'll find all 3 of them. Okay? Ready, set, go. Somebody with a calculator. Or multiple people. Everybody should know how to do this. Okay? Graph it. Find the zeros. Or maybe just use the table. The table might be faster than looking at the graph, actually. Go to y equals. Type in the function. I personally would just go straight to the table and see if I can find all 3 zeros from the table. Graph it on y equals. Go to graph.
It's going to be negative 1, 2, 5,
table.
2. I got it.
Find the zeros.
How do I change my...
Table's counting by. Go to table setup. It's above window. And tell the table to start at 0 and count by 1s or whatever you want it to do. Yep. Jack, you said you found them?
Yeah.
How many did you find?
3.
Oh, sweet. Okay. What are they?
Negative 1.
So, here are the zeros of that function. This one was easy. You found all 3 of them using your graphing calculator. No real crazy synthetic division to be done on this one. You found all 3 zeros. We know that's all of them that there are because 3 was the highest power we saw in the polynomial. Okay? So it said solve for all the zeros, roots, solutions. We did that. Here are the 3 zeros. Write the polynomial in factored form. If negative 1 is a 0, what is a factor?
X plus 1.
X plus 1. X minus 2, X minus 5. Okay? Why is it opposite? Well, think about it. If 2 is a 0, that means if I plug a 2 in for x, I will get 0 for y. Oh yeah, 2 plus 1 is 3, but what's 2 minus 2? 0, and 0 times whatever these are is still going to give you a y value of 0, so that's how you know 2 is a 0, because if you plug in 2 for x, you get 0 for y. It's always opposite whatever these are. Simple enough there? Questions on that? Alright, unfortunately they're not all that easy. Let's do this one. X to the 4th, 2x cubed What's that?
Are we gonna try and graph this one?
Yeah, we're going to have to. X to the fourth plus 2x cubed plus 6x squared plus 18x minus 27. I didn't even write it as a function this time, I just wrote the expression, okay? Let's find all the roots, zeros, or solutions. So in other words, you set it equal to 0 and solve. Is essentially what you're doing. How many will this one have?
4.
4. Hopefully some of you with the calculator that don't do much for note taking have already entered it in, so you can help us out in that way.
That's me. Oh gosh. It's already entered also.
Oh, great.
I earned mine, and then it's second, and then told you.
Alright, so
You find all 4 of them?
1, 0.
Only 2 of them?
And -3?
So 1 and -3, is that what I'm hearing?
Yes.
Okay?
100.
So my zeros
-4 is 120.
so far are 1
Steep graph.
and -3, but I know there's got to be 2 more yet, right?
Yep.
There's got to be 4 zeros. Okay. Now we do synthetic division, okay? Or long division if you prefer. Anybody? No takers? Me neither, all right? Long division is no fun. But really, here's what you are doing. I bring up long division because that's really what you're doing. If 1 is a 0, x minus 1 is a factor. You guys agree? So, what I could do is I could take this long polynomial and divide by that factor. Because when you divide by a factor, it's going to come out evenly, right? Like if I take 63 divided by 9, that'll come out evenly because 9 is a factor of 63. Okay? X minus 1 is a factor of this. So if I take this and I do long division and I divide by x minus 1, it would come out evenly. Or if I divide by x plus 3, it would come out evenly. Okay? Well, instead of doing long division twice, instead of taking this, dividing it by x minus 1, then dividing that by x plus 3, I'm going to do synthetic division because it's much faster. Why am I doing that, you say? Well, if I divide this by x minus 1, that would get me down to an x cubed polynomial. Then if I divide again by x plus 3, it would get me down to an x squared polynomial. And if I can get it down to an x squared polynomial, I know how to solve it. I can solve it using square roots, I can solve it using the quadratic formula. Okay, whatever it takes to solve the remaining quadratic. Okay, so that's why we're going to use synthetic division, to try and get this polynomial right here down to a quadratic function, down to an x squared. Okay? So, synthetic division, little refresher. Whatever the 0 is, you put that number right here in the upper left-hand corner. I always said put it in the box. Okay? So 1 is a 0, I put it in the box. Then out to the right of the box, I write all the coefficients out. And if they ever skip a term, like let's say there wasn't an x squared in this polynomial, make sure you put a 0 as a placeholder. Okay? So there's 1x to the 4th, 2x to the 3rd, 6x squared, 18x's, and negative 27 is my constant. Take the first number, I drop it below the line. 1 times 1 gives me 1, I put it here, and then I add. I'm always adding. Multiply this number here by the number in the box, put it underneath 6. Add. Add. And unless you did it wrong, you should always get 0 back here. Okay? Ask your questions.
That's cubed, right?
So what I just did was I just divided by x minus 1. I took this polynomial and I just divided it by x minus 1. And I got 1x cubed, because I reduced the power by 1, because when I divide by x, it's going to take x to the 4th and reduce it down to x to the 3rd. So 1x cubed plus 3x squared plus 9x plus 27. That doesn't help me though, because I want to get it down to a quadratic. Well, so now all you do is you use the other 0 and do it again. So I put negative 3 in the box. I use all these numbers. bring the first number all the way below. That'd be negative 3, be 0, 0, 9, negative 27, 0. That'd be x squared plus 0, x plus 9.
Did you say x squared plus 9?
X squared plus 9. Yep, I'm just showing that 0 there for our other two. Now, we can solve for the last two zeros with this leftover expression. Right? Set that leftover expression equal to 0 and solve. Right? So I'm going to set x squared plus 0x plus 9, or I'm just going to take x squared plus 9 and set that equal to 0. Now, if you wanted to, you could use the quadratic formula, but that would be overdoing it, in my opinion, here. You can just use square roots. Subtract 9 from both sides. X squared equals negative 9. Square root both sides, and you get x equals plus or minus what? 3i. Because when you square root a negative 9, you bring the negative out in front, and make it become an I there. The square root of negative 1 is I. You get two answers. Always when you have x squared equals something, you get the positive or negative answer. So it's positive or negative 3i. So those are your 4 zeros. There were 2 real zeros, 2 complex zeros. Okay, yes?
I don't know if I'm just making this up or not, but all the zeros, like, multiplied together, is that going to be like your last?
It would have to be, yes.
So, let's say you have like your degrees like 4 and you have like something like you have 16, so you know it would be like 2s or.
Yeah, not necessarily.
Well, yeah, you could use 1s. Yeah.
Mm-hmm. There's a lot of combinations, but yes, Dakota, yeah. Okay. So I found all my zeros. And just so I don't have to use a new slide, I'm going to change colors here. I'm going to write this in factored form. So y equals, what would this be in factored form? Come on, guys, come on.
X minus 1.
X minus 1, we know.
X plus 3.
X plus 3.
Plus 3i.
Now there's two ways you can do this. You can just go x minus 3i and x plus 3i. If you don't want to use the i's there, after I did synthetic division twice, what was I left over with? X squared plus 9. If you would, instead of doing these two, just write x squared plus 9, that would be fine too. Okay? But if you want to write out all 4 separate factors, that's fine, even though these last 2 factors have complex numbers in them. I don't care. Or just leave it as the quadratic x squared plus 9. Do you guys understand what I'm saying is okay there? Or do you have questions on that? You good? Yeah, Drew.
Well, it's not about that, but what if, like, at the beginning we only found 1 0?
Okay. I'm not going to give you any like that. The thing with zeros is if they ever have one imaginary, they actually have 2. They always come in pairs. Because it'll always be solving a quadratic. And when you solve a quadratic, you're always going to get 2 of something. Okay? So if there's one imaginary one, there has to be 2. So that will definitely be the case. And then the other 2 that are left, the thing is too, both of those would have to be rational. Or nice numbers is kind of what I mean by that. Because also the long decimals, the never-ending decimals, the square root of 2 or something like that, they also always come in pairs. You know, it's like if the square root of 2 is a 0, negative square root of 2 is also going to be a 0. It's just automatic. So I guess you wouldn't have that instance. Now you could have one where if it was x to the 5th power, then you could potentially just find one nice one, and all the other 4 are complex to some degree, but I'm not going to do that to you. It would require you to have a computer algebra system or a solving system where you'd have to input it, or like Wolfram Alpha, if you do that ever online. It's a math website. You can enter it and they'll tell you all the zeros. But I wouldn't do that to you. I will always give you ones that you will be able to do synthetic division to get it down to a quadratic, and then use either square roots or the quadratic formula to find the last two. Okay? But good question. Okay? Anybody else? Questions on this? Or anything related to this right now? Is this ringing a bell from algebra?
Yeah.
Okay, anything?
You could probably sing that song again, I remember.
Oh, could I?
Yeah.
Nah, I got a kind of a bad voice right now. I'm not in my performing
You can sing
state.
I don't know. That's the thing.
I mean, if you want me to sing, you want it to be good, obviously. So.
I ain't good at that, so.
All right, let's do one more and review the quadratic formula. All right, so let's solve this one. So again, you go to the calculator, find it, right? For time purposes on the video, I'll save us. It's 4. So then, put 4 in the box, do synthetic. So I get x squared minus 5x plus 3. Well, you can't factor it, because if you were able to factor it, you would have seen all the zeros on the calculator. And there's nothing that multiplies to 3 and adds to 5 as far as nice numbers go. Okay? You can't use square roots. Okay, you can't just do x squared by itself and then square root both sides. That doesn't work with that x term in there. So unfortunately, you got to use your quadratic formula. Okay? So you set this equal to 0. X equals the opposite of b. Plus or minus square root. B squared. So 25. Minus 4 times a times c all over 2a. So in this case, 2 times 1. So negative b plus or minus square root b squared minus 4ac all over 2a. (25 minus 12) would be 13. Can you simplify the square root of 13? No. Nope. So I'll leave it as 5 plus or minus the square root of 13 all over 2. Can't do anything with that. Okay? So those would be my last two zeros. 5 plus the square root of 13 over 2, and 5 minus the square root of 13 over 2. If you don't want to write them out twice separately, if you just want to write it once and put the plus minus in there, that obviously will suffice because that represents the two zeros there. Yes, Derek?
Did we do the proof for that last year?
Yeah.
Okay.
Yep. So we found the 3 zeros. Let's write our answer in factored form. How do you think you'd want to do this? Well, what's one of the factors?
X minus 1.
X minus 4. Let's take care of these. Now, there's two ways you can write the other ones. There's the way I'd probably do it because it's nicer, and then there's the way that's not so nice, but it's still right.
2 squared plus 2 the rest of it. Did you put that?
I'd probably just put this. X squared minus 5x plus 3. I'd probably just put this. If you want to write x minus 5 plus root 13 over 2, and x minus 5 minus root 13 over 2, you can. It's not wrong. Okay.
Would they both be like subtracting since they multiply?
The way I would write it would be this. X minus 5 plus root 13 over 2. I put that term itself in its own parentheses. And then the other one, x minus 5 minus root 13 over 2. If I were to do it. Just because, yeah, you would have to, if you wanted to, you know, multiply them back together, you'd have to be very careful with all the signs. It would stink, but I mean, you could do it. But yeah, so if you do it, put them in its own little parentheses like that. Right. How do you know if your factors are right? How do you know if these factors are correct? Multiply them back together and you should get what you started, right?
Do we have to find like the actual zeros if we're just going to use x squared minus 5x plus 3?
Yeah, because the directions will say find all the zeros. So that will require you to find them all. But if the directions did just say write this polynomial in factored form, then you wouldn't have to. Because you would know that this can't be factored any further. Okay? So those are just some quick refreshers on how to find all the zeros and write them in factored form.